Ethernet-based control is the biggest thing to hit car washing in 30 years. Each one of these VFDs has been made into its own little mini car wash controller with the use of Ethernet. That allows us to talk in both directions to each VFD. So for a blower, if I want to run that blower at 3 speeds, with relay technology, I need to wire 3 relays into a VFD in order to control that speed. With Ethernet, it is still just one Ethernet cable going to each drive, and we can tell the drive what RPM to run. We get bidirectional feedback, so we know it's running at that speed, we know amperage, we know what's going on with that whole little control system. So when you look at a high pressure pump, we're looking at the pressure transducer and low water coming back to the VFD. The HMI reads the status of those inputs to know that that drive is working correctly, that there's enough water, we're at the right pressure, the RPM is correct for the pressure we want, and the amperage is correct for the RPMs that we're running and the load that is on the pump. So each little VFD in this panel becomes its own controller, which is nice. It distributes the whole control process, reduces wiring, and makes it simple because it's easy to look at one little thing as opposed to the whole car wash system with a lot of wires. The other thing we do in a VFD panel that is very important, heat is the biggest cause of failure with VFDs. So we air condition these panels. Harmonics is also a big problem with VFDs. As you change the sine wave of electric, it creates all kinds of electrical disturbances in your car wash. We use a line reactor at each VFD to prevent those harmonics from going back into the car wash or into the control system. So air conditioning and line reactors to control harmonics are essential to deploying VFDs reliably in a car wash.